Greetings, mathematicians. Here we are again, another math lesson. Today we are looking at equate and compare decimals. And we should be looking at 16L and 16R in our notes. I'm at the last day of September. I don't know where you at, if you're in another class. But if you need to pause for a moment to get this in your table of contents, go for it. Otherwise, stick with me. All right. To save for some time, I have worked out a bit of a frame. Before you do anything, make sure you've got your pages numbered, 16 left and 16 right. Let's zoom in just a bit. All right, Unit 2, Lesson 3, equate. Say with me, equate and compare. Let's do that again, equate and compare. And we are going to, I'm missing a word. Decimals. So we're going to equate and compare decimals into the thousandths. Oh, boy, did I mess that one up. All right, let's look at our objective. I will model and identify equivalent decimals, all right, and our conjunction, compare decimals into the thousandths. So just a quick reminder, we had talked about deci in the previous lesson. That prefix means what number? Deci means 10. So we need to remember that all of these decimal places can be converted into some sort of fraction because of the place value, tenths, hundredths, thousandths. Next up, we are going to compare as our verb. A reminder, comparison is greater than, comma, less than, comma, equal to. I'm sure you memorize these symbols using some form of mnemonic device, whether it's the alligator opens to the bigger number, or if you're pointing at the smaller number. And that last symbol we have here is our equal sign, and that's going to connect to this term, equivalent. Say it once with me, equivalent. All right, now say it to the ceiling, equivalent. The root equi means equal. So we are looking for equivalent or equal decimals. Let's make sure we have the whole frame. We found equivalent fractions in Unit 1. Let's see if we can figure out what an equivalent decimal is in Unit 2. And hey, shocker, here's our vocab term, equivalent decimal. All right, and our example of an equivalent decimal, many of you might know this already, and some of you might be a little confused, but let's come up with our example. And I'll make it a very simple single digit. So I've got 0 and 6/10. So this is the place value is 10th, 6/10. And we're going to say it's equal to 0 and 60. What place is the 0 in? This is in the hundredths. And I'm going to show you why they're equal. First off, we can go by place value. Look at the ones column, both 0. Awesome. Decimal, move to the next column. They both have a 6 in the tenths place. And if I go to the next one, I have a 0 in the hundredths. I have nothing here. If I have nothing, is nothing equal to 0? Of course it is. Now I'm going to show you why. Let's convert this to a fraction. And we can do that just by saying it out loud. 0 and 6 what? Tenths. So that turns into 6/10. Let's say this number, 0 and whole number, 60. 60 what? The 0 is in the hundredths. 60 over 100. Why would these two fractions be equivalent? That's the question we need to answer to make this connection. And if you said simplification, you're absolutely right, because if I take this fraction and I divide by 10 and I divide by 10, I will end up with 6/10. So that is why these two decimals are equivalent. They both have a 6 in the tenths. They have nothing in the hundredths. They are equivalent. Let's go one step further, and I might run out of space. It is also equal to 0.600, or as we say it in 5th grade, 0 and 600 what? That's right. This 0 is in the tenths, hundredths, thousandths place. So we could say that this fraction is 600 over what place? 1,000. Now, oftentimes I'll look at these zeros. If everything matches up in that first place value, everything else, we could have a million zeros to the right and it would still be an equivalent decimal. All right. So place value is key. We need to look at that place value and match them up. All right, so this is all about our equivalent decimals. Let's move to the next page and we'll talk about some comparisons. And let's look at a very simple comparison. Let's start with the number 17, one of those big holes in the middle, and 9. Which is bigger, 17 or 9? You're absolutely right, 17 is bigger. So I would go ahead and put greater than. So 17 is greater than 9. Cool. What about 0 and 1700ths compared to 9/10? If we were comparing these two decimals, which one would be bigger? Well, here's my trick. Think about money. So whenever we're using money, we have two decimal places. So if we had to think about this, let's put a $sign over here. How much money is this? 17 cents. Cool. Now I'm looking at 0.9. I'm missing a place value here. So if nothing's there, I can put in a 0. Sure. Now if we put a $sign on there, how much money is that? 90 cents. Which one's closer to a dollar? 90 cents or 17 cents? Absolutely right. So this would be less than. 17 is less than 90. So wherever the decimals end up can really change what we know about the numbers. Let's do one more. Let's look at 73 compared to 138. This one's easy. Which one's bigger? You're right, 138. We have 100, Mr. McNeil. Of course it's bigger. So if I read it left, right, 73 is less than 138. All right, let's throw a decimal in and see what happens. 0 and 73, 3's in the hundredths place, compared to 0 and 138,000. Now, that money trick works down here, but remember, we're only going to read the first two decimals. So let's pretend they're money. This is 73 cents. This is 13, almost 14. Because if this were a little bit bigger, this would turn to a 4. So which is more, 73 cents or 13 cents? That's right, 73 is greater. As we go further and further away from 0, these places count for smaller amounts, smaller and smaller pieces. All right, my friends, there will be some Think Central questions for you. And I think we're going to call this one Unit 2, Lesson 2, PMT for Personal Math Trainer homework. This year it's not homework, it's classwork. You guys can get this done, and I'll check in with you later.